Okay, 3, 2, 1, and go. Here we are. We are going to talk just a little bit about review, what we did right before break, and then we're going to go into dividing radicals today. And just as a review, we're going to list off the perfect squares. I'll list off the first few that everybody know. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. What is 6 squared?
36.
7 squared?
49.
8 squared?
54.
9 squared?
81. 81.
10 squared is 100. What about 11 squared?
121.
121. Then?
144.
144.
169.
169.
196.
196.
255.
225.
25.
And 256. Okay? So, there's our perfect squares. I'm going to give you that list on the test, but you have to know how to make use of them. You have to know how to multiply and divide with them. So, we worked on simplifying radicals and adding and subtracting radicals. True or false? I can subtract these two radicals right now.
True.
True. Why?
Because they're the same.
Yeah, because the radicand is the same. Whoop. Come on back. There you go. So this radicand is the same. So I'm going to go ahead and I've got the root of 7, root of 7. So 2 roots of 7 minus 5 roots of 7 is negative 3 roots of 7. Okay? Can I add the next two?
No.
No. I have the square root of 18 and I have the square root of 50. So I need to simplify these first to see if they have a common radicand. Square root of 18 divides up in what two parts? 9 and 2. We like 9 and 2 because 9 is a perfect square. If you would choose 6 and 3, those wouldn't work because neither 6 nor 3 is a perfect square. What's a perfect square divides evenly in 50? You have 25 and 2. So there we have it. The square root of 9 times 3. Square root of 9 is 3 times 3 is 9. So the first one becomes 9 roots of 2. And we add that to, the square root of 25 is 5 times 4 is 20 roots of 2. Can I now add them together?
Yes.
Yeah. They have the same radicand of square root of 2, so I have 29 roots of 2. Okay? So if you're able to simplify radicals and add them together, you're in pretty good shape moving forward. Okay? In order for a radical to be simplified in terms of dividing, it must have all perfect squares removed. Okay, got to remove all perfect squares. And no radical in the denominator. I think that most everything in math is absolutely awesome. I think this is the dumbest rule in mathematics. I don't really see why it's a thing. I think it's silly. They say that there can't be a square root in the denominator. Fine. We'll go with what they say. We won't allow there to be a square root in the denominator. Okay? So, in example 1, there is currently a square root in the denominator. And the reason why is you can break square roots up into the top and the bottom. So in the top you have the square root of 4, and the bottom you have the square root of 9. You're allowed to break them up that way. Okay? This works out quite nicely, because what is the square root of 4?
2.
The square root of 9 is?
3.
So, square root of 4/9 is just 2/3. That was nice and simple. Notice all the radicals are gone, so you know you're done. Next one, what will the square root of 25 over 49 be? 5 over 7, and then the square root of 1 over 256 is 1 over 16. So you can see that if you can take the square root of the top and the bottom, nice and easy, no worries. Next one's a little bit different. Notice in the top, you have the square root of 6, because you cannot reduce the square root of 6. But what do you have in the bottom?
5.
5. Am I okay to leave it like that? Yeah. There's nothing that you can take out of the square root of 6 that's a perfect square, and there's no square root in the denominator. The next one, there's a negative out front. Don't worry about it, just write negative. And you have the square root of 2 on top, and what do you have in the bottom? 7. Notice again, there's no square root in the denominator. Next one, you got square root of 7 in the top. And in the bottom, you have 10. Again, there's no square root in the denominator. Well, look at the next one. If you were to write this as the square root of the top, which is 2, and the square root of the bottom, which is 3, notice you get the square root of 2 over the square root of 3. Can I leave it like that? No. There's no perfect square that you can remove, but you can't have that square root in the denominator. So what do?
Times by the root of 3.
Good. Carly sees it. We multiply the top by the root of 3 and the bottom by the root of 3. Let's talk about why you're allowed to do that. What is the square root of 3 over the square root of 3?
3.
Blah.
1.
1, right? Something divided by itself is 1. So you're allowed to multiply anything by 1 and you don't change the value of that expression. But it does change the way that it looks. The square root of 2 times the square root of 3 is the square root of 6. And then the square root of 3 times the square root of 3 is the square root of 9. Now you're like, well, Mr. Gens, you said we were going to get rid of the square root in the denominator. Well, I did, because what is the square root of 9? It is 3. Notice how you get the square root of 6 over 3. That's done. There's no perfect square you can take out of 6, and 3 is not, or does not have a square root around it, so you're good to go. Next one, I've got a square root of 2 in the denominator. That's a problem. So what are you going to do?
Times by the root of 2.
Root of 2 over root of 2. And at the top, you get the root of 10. In the bottom, I'm going to skip the step this time and writing it down. What is the square root of 2 times the square root of 2?
Square root of 4.
Square root of 4, which is
2.
2. I'm done. Yes, if you take a square root of something multiplied by itself, the square root just disappears. Okay, square root of 3 divided by the square root of 6. I'm going to show you, a lot of people would want to multiply top and bottom by the square root of 6, right?
Yeah.
Can I show you a different way that's going to go faster?
Sure.
Is there a number that divides evenly in both 3 and 6?
3. Yes.
3. So watch how I'm going to write this. The square root of 3 divided by the square root of 3 times the square root of 2. See how I broke square root of 6 up into 2 parts? Those reduce.
Wait.
And I just get 1 over the root of 2.
What? But you.
I can't leave the square root in the denominator, so I multiply top and bottom by
2. What? 2.
square root of 2. In the top, 1 times the square root of 2 is just the square root of 2.
Over 2.
In the bottom, you get 2. So if you reduce ahead of time, that can avoid getting larger numbers. For example, if you were to multiply top and bottom by 6, you get the square root of 18. Now that's fine if you want to deal with square root of 18, but this is a way to kind of reduce the size of the numbers. Next one, there's nothing that divides evenly into 10 and 3, so we just have to multiply top and bottom by the root of 3. And in the top, we have 6 roots of 30, and in the bottom, we have what? Just 3. So the square root is gone, but does something simplify there?
The 30.
6 divided by 3 is
Oh.
2. 6 divided by 3 is 2, so you have 2 square roots of 30. There's no perfect square that divides evenly into 30, so that's it. Try example 11 on your own. Try 11 on your own.
Mr. Gens, did I do this part right? Is that the right way to do it?
but then you have to reduce the square root of 18.
Yeah,
Just
just
take
throw
out
the
9.
9
Oh,
on square
yeah.
root of 2.
Yep, good job. Yep, you got it. Good job.
Sir.
Yep, good, excellent.
I'm gonna multiply top and bottom by the root of 2 and get 8 roots of 14 over 2. Notice how 8 divided by 2 is 4, so you should get 4 roots of 14. 4 roots of 14. Last example we do together, a lot of people would be tempted to multiply top and bottom by the square root of 35. If I did that, I'd get the square root of 350. I don't like to work with 350. It's a really big number. What's a number that divides evenly into both the 10 and 35? So what I'm going to do is I'm going to divide that 5 out. I'm going to write negative 4 times the root of 5 times the root of 2. Over, and in the bottom I'm going to write the root of 5 times the root of 7. So this is a way for me to avoid working with that square root of 350. I notice that the 5's reduce, and I'm left with a new problem. Negative 4 roots of 2 over root of 7. Can I leave that as my answer?
No.
What do I do? Multiply top and bottom by the root of 7. And I get negative 4 roots of 14 over 7. And that's it.
Great.
But did I tell you I'm not here on Friday? So on Friday, I will not be here. I have a